Alright, so this is our first video. We're actually going to watch this one in class, which you already know because you're sitting in class when you're watching this. Alright, so our first video, video 1.1, is just introduction to functions. Okay, so on this slide, if you ever see a slide with a bunch of definitions on it, let's exercise our problem solving skills. And I'm not going to sit here and spend 20 minutes on each of these definitions. So I would pause my video. Obviously we're in class, so I'm controlling that. But I would pause my video here. I would copy these down. I don't care. I may have already said this, but I don't care if you use a composition book, a spiral, your Microsoft Surface that your Guardians bought you, your loose leaf paper, and you throw it in a binder. I don't care where your notes are. But you're going to want to have them handy in class, because if you have these definitions, it's going to make your work in class 1,000 times easier. I won't say it's going to be impossible without them, because we'll still discuss, but it will be a lot easier if you come to class just with the definitions written down and any examples we do. So here's our definitions. I didn't mean to click off that. A relation is a mapping or pairing of input values and output values. Basically anything in the world is a relation. We have to define it only because we care actually what a function is. So a function is a relation for which each input has exactly one output. Basically, really fancy way of saying each x value has a y value. But x values never repeat. So if you have the point 4,2 on a graph, you can't also have the point 4,4. And we're going to get that more in depth a little bit later in the video. Domain. The fancy definition is input values, but we're just going to call those x values because that's generally we're going to be graphing. Range, that's our output values. Again, simpler terms. Domain is x, range is y. So how do we know if something's a function? Basically, I don't care if it's a relation. A relation really doesn't help us much. But we do care if it's a function, and we do need to know the difference for our first couple units, because if it's not a function, basically you get to circle the answer choice, not a function, and you're finished. So how do we know if it's a function? Well, first, do the x values repeat? So when you're looking at the points or you're looking at a graph, if the same x value has multiple y values, so like 4,1, 4,2, 4,3 are all points on the graph, that would not be a function because the x value of 4 in 4,1, 4,2, 4,3 just happened 3 times. So if an x value repeats, no good, not a function. There's also something called a vertical line test. It only makes sense if you're looking at an actual graph. If you're just looking at a series of points, it's essentially worthless. But there will be a lot of times we're looking at a graph and I show you a circle or something and I'm like, hey, is this a function? But it operates under the same principles. Do the x values repeat? So we're literally going to take a pencil or pen, whatever you have, use your finger, it doesn't matter. And we're going to draw a straight vertical line, verticals up and down. We're going to draw a straight vertical line and just kind of move our pencil across the graph. If at any point that straight vertical line hits 2 points, it is not a function. Because if your pencil or pen, the vertical line, hits 2 points, then that means that x value happens twice. If it hits 4 points, that means that x value happens 4 times. And if the x values repeat or happen more than once, then it is not a function. I would be writing this down as well. Maybe not word for word, but the gist of it. Whatever you need, when I say vertical line test, whatever you need underneath that you understand what we're talking about. All right, so here's kind of a quick example. So we have the relation, and I'm not going to read the points off, but there's 5 points. And number 1 says, what's my domain? Well, if we recall, which we should recall because we just wrote down the definition of domain in our notes, hopefully, hint, hint. The domain is our x values, or our input values. So literally, when I ask you, what's the domain? For now, we're going to get more in depth later. That's hideous. There's this little set notation thing. If you just want to draw parentheses, I'll be forgiving. Domains are x values. So look at all 5 points, and you just have to list the x values. Now these are in sequential order, so smallest to largest. That's just because I'm nice, I guess. If it's not in sequential order, go ahead and write it that way. I'm not going to count off on a test. It's just standard protocol. So you want to write the smallest number to the largest number every time. And when we get into the different notations, you're going to want to know that anyway. So just go ahead and lock that in your brain. Smallest number goes on the left, then just greatest number goes on the right. So we said our domain is all our x values. Range, if you look 3 inches up on your page at what you wrote for the definition of range, range is our y value. So the range of these points, we're just going to list the y values. So we're going to do the same. My pen's not working. The same squiggly bracket, and we're just going to list the y value. So -3, 1, 3, -2, 1. And this would, what in the world is my pen doing? This would be a good example of, see how we're not in smallest to largest? So if you just list them off, again, I'm not going to dock points off your test, but just know that technically I would want to see -3 is the smallest, then -2, then we have 1 happens twice, right? We see that I have 1 twice. If it happens twice, you can repeat it, but you only technically have to write it once. Or writing the range, you don't have to write the repeat values. And then we have 3. At the beginning of the year, I am going to go ahead and write these twice because we're trying to figure out is something a function or not, and that is important. So either one of these is fine, but the bottom right, the lower one, is actually better because it is in smallest to largest order, so or greatest or least to greatest, however you want to say it. So is it a function? If you look at how we define a function, we said it is a relation is also a function if the x values don't repeat. So in order for it to be a function, my x values can only happen one time. If you look up at the first bullet where we define the domain, we said -2, -1, 1, 2, and 3. The x values did not repeat, so is it a function? Yes. You literally just have to say, did the x values repeat? No. Check. We're good. All right. When you see me writing, when I say I'm going to switch slides, the writing's going to disappear. So make sure you pause it if you're still copying this down on a normal night, because this is in class. And this is going to be a longer video because I'm explaining a bunch of stuff. Normally we'll just get down to it. So there's that slide. Let's see how everything disappears. So for each of the following, determine if the relation is also a function. These crazy bubble things, if you've never seen them before, it's called a mapping diagram. Basically, it's the same information I just gave you, where I gave you the ordered pairs, except here we write all the x values in the left bubble, all the right values in the right bubble. And if you look at this point right here, that's the point 3, -3. What the x value, you draw an arrow to the y value, and then it makes the ordered pair 3, -3. So that's how you read these if you've never seen these before. Okay, so if it is a function, then my x values cannot repeat. So I have 3, -3. Then I have 4, 0. Then I have 5, 16. Then I have 6, -5. Ooh, that's bad. What in the world? So, whatever. we have 6, -5. I just won't highlight that. I never said the same x value twice. So, since no x value repeats, yes, that one on the left is a function. On the right over here, I'm trying to trick you a little bit, we have -6, 4. We have 0, 3. We have 2, 5. And we have 4, 4. If you look, the 4 x value and the -6 x value both go to the y value of 4, but the x values are different. So if you look, I have 4 points and 4 x values, and I know I have 4 points because there's 4 arrows. 4 points and 4 x values, which means my x values do not repeat. So is it a function? Yes. And I know this one's kind of tricky because the y values repeat. But if I have 4 arrows and 4 x values, yes, it's a function because my x values did not repeat. All right, so vertical line test. This is what I was talking about earlier. The red dotted line is the pretend vertical line that we would draw. You can draw that red vertical line wherever you want. If you look at the far left, the one that looks like we're riding our bike through the hills, the red vertical line only touches the graph one time, so it is a function. If you look at the middle graph, the C-looking graph, you see that the red line touches the graph here and here. So since it touches it twice, it is not a function because that x value repeats. If it hits the graph twice, it's no bueno. The third graph, you see it hits here and here. If it hits the graph twice, it's not a function. Vertical line test hopefully is kind of intuitive. If you draw a vertical line and you hit the graph more than once, the answer is no, not a function. If you hit the graph once, the answer is yes, it is a function. All right, so that's video 1.1.